Welcome to another exercise in the workbook statistics. This time with an exercise focusing on t-test for coefficients and the f-test. So let's have a look at the exercise. In the context of a market research study, you're asked by your boss to find out whether a relation exists between the age of a person, X, and the time spent on consuming news. In the first pre-test, you collected the data summarized in the table below. And we have this data here. So for 5 participants, we have the age and the daily news consumption in minutes. Our task: first, determine the coefficients of the regression line that describes the relation between age and the duration of news consumed. And second, in the context of the analysis, you get a coefficient of determination of r squared equal to 0.72. Use a suitable test to check if the relation is significant at an error margin of 5%. Well, let's start with the regression line with part A. Here in part A, we're going to copy the table we had with age being X, the independent variable, news consumption being Y, the dependent variable, and we're going to add one additional column for the averages of what we're going to calculate here. That's the first part, adding this new column, and then we're going to add 2 additional rows. In the first row, we're noting all the X values squared, so all of this to the power of 2, giving us these values, and thereof we're also taking the average. So the average of these values is listed here, and a second row where we list X times Y, so 15 times 5, 28 times 15, 42 times 20, and so forth. Again, of all these values, we are calculating the average. Once we finish this table, and in particular this last column, we have everything we need for the coefficients of the regression line. Because the formula for the slope reads as follows: the average of X and Y, that's here the 489, minus the average of X times the average of Y. So minus 29 times 14. And we divide all of this by the average of X squared, which here is the 934.2, minus the average of X squared. That's the 29. So 29 squared here. If we put this into a calculator, we get as a result for the slope 0.8906. This slope parameter we can then use to determine the intercept of the regression line. The intercept we get by starting with the average of Y, which here is 14, minus then the slope of 0.8906 times the average of X, which is 29. Which gives us in total for the intercept a value of minus 11.8274. That's everything we need for the regression line, which can then be stated as follows. So that's our regression line, that's the line we're going to use in the next context. Well, that was already part 1, so we can continue with the second part. Second part where we already have an R squared. So if we actually want to test whether the model has significant explanatory power, what we're going to do here is conduct an f-test. Because, well, with the addition of the r squared from the exercise text, we have everything we need for this f-test. So first we're going to calculate our test statistic. And the test statistic for the f-test simply is r squared divided by k. K is the number of independent variables. So our r squared was 0.72 divided by 1, since we only have one x variable. Then we're going to divide this fraction by another fraction, where here we have 1 minus r squared, so that's 0.28, divided by n minus k minus 1. N is the number of observations, and here we had 5 observations, so we have 5 minus 1 minus 1, giving us 3. Then we're going to divide these 2 fractions, giving us a test statistic of 7.7143. This test statistic we then, for the test itself, have to compare with a reference statistic. So that's the thing we need to determine next. The reference statistic for the f-test is given as f k n minus k minus 1 and 1 minus alpha. K we have here as 1, n minus k minus 1 we have as 3, and alpha, that's our margin of error. And here the exercise text stated of using a margin of error of 5%. So if you use 5% or 0.05, we get 0.95. Meaning we're going to take our table for the f distribution and look up the value f130.95. There we're going to find the value 10.128. So that's more or less all the stuff we have to do, calculation or looking up wise. Then for our actual test, we're just going to compare test statistic and reference value. Here we see that the test statistic is smaller than the reference value. This means we cannot reject our H0 hypothesis. The H0 hypothesis for the f-test is that our model does not have significant explanatory power. So even though the R-squared is 72%, since we only have 5 observations, which is very, very few, we cannot reject H0. We cannot assume that this is actually a significant amount which we can explain with our model. And well, that's then everything there is also for this model, for this exercise. And well, I hope you enjoyed it. I say goodbye and see you next time.